All right, good morning, everyone. It's week 3, day 1. We're here on our morning algo session. Today's algo is called two-number sum, and let me explain the instructions here. Okay, I want us to write a function that takes in a non-empty array of distinct integers. So the array will have different integers, like here, distinct. There's no doubles. 2, 7, 11, 15. Those are all distinct integers, all right? Distinct integers, and an integer representing a target sum. So in this case, the target sum is 9. If any two numbers in the input array sum up to the target sum, the function should return them in an array in any order, okay? So those two numbers that add up to the target sum, return them in an array. Doesn't matter if it's any order. So 2 and 7, those add up to 9. So you would have to return an array like this, an output of index 0 and index 1. Those two values add up to the target sum. Doesn't matter if it's 1, 0, 0, 1. This answer, it just needs to contain both indexes that have that target sum. If no two numbers sum up to the target sum, the function should return no sum in the array can be found. Okay, so if no two sums add up, you have to have a return that accounts for that. You got to return no sum in the array can be found. Note that the target sum has to be obtained by summing two different integers in the same array. So it has to be two different integers in the same array. You can't use another integer to get that target sum, right? You can't add a single integer to itself in order to obtain the target sum. So you cannot add an integer to itself. So you have, like, for example, 1 in the index. You can't just add 1, 1, 1, 1, 1 to get to the target sum to itself. Also, you can't assume there will be at most one pair of numbers summing up to the number. So you can assume there will be at most one pair. At most one pair. So there will only be one pair in this example. So whatever target sum you are given, you should assume at most one pair. So there will only be one pair in the whole array. Don't worry about getting all the possible target sums. Just get the first one, because you can assume the first one is the only one. Okay, so in other words, given an array of integers, nums, and integer target, return indices of the two numbers that they should add up to the target. You may assume that each input would have exactly one solution. You may not use the same element twice. Okay, so I will go ahead and paste this into Discord. And that's about it. Does anyone have any questions? Does everyone understand the problem? Fairly simple algo, right? Okay, we're going to build upon how we learn how to do this tomorrow. It's going to be a slightly harder challenge tomorrow morning. All right, so I am loading Discord so that I'm going to stop sharing my screen, pause the recording. You guys don't have any questions, right? Nope. Okay. Recording. All right. Who'd like to present? Who'd like to present first? There's only one group that's going to present. It's only one question, right? So I will call on a group if we don't have any volunteers. Shakira's group, would you like to present then, please?
Sure thing. All right, give me 1 second. All right, so pretty much what we were going through is we made 2 for loops. So we started off with for loop number 1 and then for loop number 2. We got our T diagram down here. So when we start where variable I equals 0, so we start there. Then we go through our for loop, and then we have variable first num equals position I. which is 0 in this case. So that's the second step. All right, continuing on our for loop, then we go and check where our first num is 2. Excuse me, that's the number that's actually in the array. And then for this part, then our second number is going to be num's position j.
Hold on a
which
second.
is-
Sorry.
Yeah.
Let's explain the second for loop and how it's different than the first. So the J,
Okay.
where does J start? And where does it
Correct.
end?
So J, to alter the first for loop, so the first one's just going to find the array spot of 0. So the first variable here as J is going to be +1. That's going to be the main difference because it's going to be one iteration further along in the array than position 0. And then when we come into here, we're going to take those two numbers and then we'll go ahead and compare them with our second second number equals target. And then if that is true, we will go ahead and return just the array positions. So that is done by the variable nums, array of I, array of j. If we get all the way through our loop, or both loops, excuse me, and neither of them equal our target number, we never hit this if statement, we will go ahead and return, no sum in the array can be found. And there is 2, 1, 7, and true. Helps
Awesome.
to t-chart it when it's the first two numbers.
Okay. Okay, so this is one solution. Let's keep this up before we close out. All right, one thing I'd like to introduce this week for solving algos, because this week is going to be a different challenge level. All right, whenever we're solving algos and we're discussing with each other ideas, possible solutions, what we want to do is pseudocode. Okay, pseudocode, which means just write out in plain English what the logic is that will help you find the solution, right? So in this case, we determined, okay, so if we start at index, we have a first for loop, we start at index I, then we have a second for loop that starts at the index to the right of I. And so if you write that logic out to compare those two values, you can write it out in plain English. All right, that's called pseudocode. Just write it out, the logic in plain English, so that you can follow your own directions, translate your English logic into JavaScript logic. Okay, so that's what I want to see more of this coming week. Whenever you guys are let's say having an idea to run a couple for loops to check two values next to each other, right? Before we go in through the logic and try and, we get into the nitty gritty, we get messy here trying to write different console logs to see if our solution is actually a viable one. We want to write it down so that we know that our JavaScript logic is actually equivalent to what our targeted goal was, our idea that was going to solve it, that we wrote in plain English. All right, so you can use this method on an interview as well. I've used it plenty of times, and interviewers want to sometimes see how you think, how you work a problem, how you can talk your problem solving skill out loud. Sometimes that's more important than the solution itself. Okay, I've past interviews where I did not solve the algorithm, but because I was able to show myself thinking out loud, writing out my different possible solutions, trying all of them, I was probably close to the solution. They gave me a really hard algo. I don't know how I would have solved it unless I maybe already was familiar with it. But what they want to see is how vocal, not just how well of a problem solver you are, but how can you express your thoughts? How can you express your problem solving logic that you have in your head out loud? And if you can translate that to code, okay, if you can do the whole thing, then that's a pass, right? But sometimes you can pass just by showing how you think and what your different problem solving approaches would be to a problem, even if you don't get it. So what I want to see you guys do is not just write code every single time, but as you are thinking out loud of an idea, get those thoughts crystallized into words and English words, just so anybody can, anybody with logic skills can read through your solution and solve it. What then you need to do after that is translate it into code. Okay, so I want to see more pseudocode these coming days, and I'll be checking for that. All right, so does anyone have a different solution they want to present before we close out? A different solution to the same problem?
So, Vincent was telling us about like, what was it, like O time optimization and stuff like that?
Right. Yes, there is optimization in your algorithms that you can solve for time and for memory. We haven't gotten into that yet, and we will have a dedicated lecture and explanation for that later on in the MERN stack and the JavaScript stack. I haven't completely introduced the most optimal way. I've kind of suggested it at certain algo points. But the first step to solving a solution is, if you don't know how to do it the brute force way, the most difficult way, most cumbersome way, and then sophisticate your answer, then make it simpler and more efficient. But first, get the solution, get some logic there that will actually work, even if it's going to take a lot of work for the computer to do. All right, so that's what I want you guys to do this week. Don't worry about optimizing your algorithm. That's something we'll help you build and do later on. First, we just want to get the problem solving thoughts to pseudocode to actual code. Okay, so that's going to be our process now. Okay, and that ends our morning algorithm session, unless we have another person that wants to share a different solution. No pressure.
We had the same solutions.
Same solution. So, okay.
Yeah.
Most solutions will be very similar anyways.
We had the same solution, but we just didn't have as much lines, I think.
Okay, so
It's a little bit different.
Same.
Little different.
Less variables.
Mostly the same. We just created variables in the last group's presentation, and we just returned the variables so we know what it is that we're returning. So we'll have this code available on the GitHub. We can take a look at it later if we want to see the solution. All right, so what we need to do now is take a break so that we can enter into our next lecture session, and I'll go ahead and start that process now. So let me stop the recording.